Hello everyone, my name is Thomas Kim. Today is April 21st, 2019. This is my 5th episode about pointer reference constant in C++. In this episode, we will learn about constant pointer and pointer to constant object and reference to a pointer, things like that. Okay, let's get started. Start Visual Studio Code. I created a file called 000 constant ptr. Include iostream void example for constant pointers. int main. I copy the function name. Okay, I declare intn and initialize 5, and I declare a pointer np1. So np1 is declared int star, where the star y is called asterisk is a declarator or a pointer declarator. Since mp1 is not initialized, it is not a constant pointer. Now let's try another one. Constant int pointer cp1. Is this a constant pointer? Is this a constant pointer? Since we did not initialize and VSC Visual Studio Code does not squiggle, cp1 is not a constant pointer. What about this? Constant character pointer MSG. It is not a constant pointer either. int pointer ptr. The star means ptr is a type of pointer. int in front of the star has 3 implications. First, arithmetic operation over ptr is based on size int, which happens to be 4 bytes. ptr plus 1 means add 4 bytes to the value of ptr. ptr plus 2 means add 8 bytes to the value of ptr. Second, when the pointer object ptr is dereferenced using star, this star is an operator, dereferencing operator. Int in front of star instructs the CPU read or fetch 4 bytes from memory. int star instructs the C++ compiler to implicitly implement array indexing operator. Now let's initialize ptr with something. Now we can assign ptr the address of n. We assigned the address of n to the value of ptr. The expression ptr plus 1 is not the same to ptr plus 1. Now let's do some examination. We initialized n with 5, and then we assigned the address of n to ptr. Now let's think about these things. std cout the address of n, like this, address of n, std and there. std cout the address of ptr, ptr std and there. std cout the value of n, std and there. std cout the value the ptr pointing to, ptr std and there. Once again, std cout the value of ptr, of the ptr std and there. Now I create here another value, another type, reference type, int reference ref n. Please understand that initialize reference with n. std cout the address of ref std and std cout the value of ref std and there. Now let's build and examine each meaning. I start command prompt clang ++o const ptr cpp a. I will make it a little bit smaller to compare. So address of n, the address of n is f4. It ends with f4. The address of ref is also f4 because reference is initialized with n. Ref, this reference does not have its own memory location. Its address and n's address are the same. Here, n's address and reference address are exactly the same. Okay, that means reference does not have its own memory. It's reference to n. Okay, now let's think about the value of ref. This syntax, the value of ref is 5. The value of n is 5. So reference acts exactly the same the object it references to. Now let's think about the pointer. In case of this pointer, this ptr is here. Ptr is the address of n. In this case, f4 is assigned to ptr. So the value of ptr, this is the value of ptr. Please watch it carefully, this line. The value of ptr is this 65fd4. So this is the value, the address of n. The address of n is the value of ptr. Now let's think about this. The value of ptr pointing to. The value the ptr pointing to. This is the reference operator. This is 5. So star ptr means it returns the value the ptr pointed to. And let's think about the address of ptr. The address of ptr is ends with this C8. So in case of ptr has its own memory location. Pointer is an object having its own memory. In case of reference, does not have its own memory location. It references to n. This value n. Okay, n's address. The address of n, the address of n are the same. So reference is not an object in this case. What about this? Constant int reference crf6. Now let's think about this. We can print out the address. The address of crf here. Address of crf. Now the value it references to. Okay, the value of crf it references to. Then we can display CRF. We can remove this ampersand. Now let's rebuild. A. Now CRF has independent memory. This CRF initialized with literal value has independent memory. So it is a full-blown object. And its value is 6 because we initialized with 6. Now let's think about this. Constant int reference CCREF. We initialize with n. Okay. Now let's consider about this. I copy these two lines. I copied the address of, I copy here and copied like this. Copy, copy. Okay. Now let's build it once again. Now the address of CCREF is DF8 because it does not have its own memory. CCREF's address is DF4 exactly the same address of N. REF, CCREF all has the same memory location. So CCREF and REF, these are alias. They do not have its own memory. They are entities, but they are not object. Object in C++, an object in C++ has special meaning. It means it has its own independent memory. Okay, so in this case, N has its independent memory. It's an object. REF, it has the same address with N, but it is alias or it is reference. It is an entity. It is not an object. Also CCREF, it has the same memory address. It is an alias. It is a reference. It is an entity, but it is not an object. Understanding this concept is really important. This is constant integer reference CREF and CCREF. These looks the same, but they are very different. In case of CRF has independent memory, so it is an object. In case of CCREF, it does not have independent memory. It refers to N, so it is not an object. Understanding whether it is an object or not is crucial, really important. It's a fundamental idea. I will change the function name pointer to constant object. I modified the function name. I copy the function name and paste it here like this. Now let's think about this. Double D1 5.0 we initialize. Constant double CD 6.0 double, this is pointer dp1. We initialize with the address of d1. Double pointer dp2. We initialize with the address of cd, constant double. This does not work normally because cd is constant double and this is pointer to double. How can we assign constant double to dp2? We need some typecast. Constant cast double, this is reference CD. We first remove constantness from constant double. We removed constantness of constant double. This is still not address. Then we take the address like this. If we want to assign the address of constant double to a pointer of type double, then we first have to remove the constantness of the constant double using typecast constant cast double reference CD. Then we now take the address using address of operator like this. Constant cast double reference CD. Now let's think another thing. Constant double pointer CP1. We can take the address of D1. It's perfectly okay. Constant double CP2 address of CD. This is also perfect. The question now is, what does constant in constant double pointer mean? Constant in constant double pointer does not mean we can assign only constant object. In this case, in CP1, we assigned the address of D1. D1 is not constant, so constant in constant double pointer does not mean we can only assign the address of the constant object of type double. Now let's think another one. CP2, we can assign another address. For example, the address of D1. We modified the value of CP2 with a new address of another object of type double. Since we modified the value of CP2, constant in constant double pointer does not mean the pointer CP2 is constant. Second, constant in constant double does not mean we cannot assign a new address of another object of type double. That is, the pointer of type constant double pointer is not constant pointer. Now let's think another way. CP1 6.7. This does not work. The dereference operator star in front of CP1, the pointer, means the value of the object the pointer CP1 is pointing to. CP1 is the value of CP1, which is the address of D1 or D1. The reference operator CP1 is the value of the object that the pointer is pointing to. In this case, the value of D1. Through this understanding, this is syntax error. Constant in constant double pointer means that we cannot modify the value of the object the pointer is pointing to. It does not mean we cannot modify the value of the pointer itself. Now let's apply what we learned so far to our C++ program. int m5 int pointer mptr address of mptr. We modified the value of mptr, for example, to 6. It works successfully. Constant int pointer cmptr address of m, the reference operator cmptr, for example 7. Now let's build and compile if it works. It does not work. It does not work. Anyway, let's compile and examine. Clang compiler CP168 is defined twice. I would say CDP1, CDP2, CDP. I fixed like this. Compile once again. At 102, this does not work. 102, this does not work. We cannot modify the value constant int pointer is pointing to. We cannot modify this way. Now let's build once again. Okay, everything seems to be working fine. Before I close this session, let's talk about colloquial terms in C++ community. Strictly speaking, this is not constant pointer. SSTS, constant int pointer, is not constant pointer, but we call it just constant pointer. And this is not constant pointer, but we call it constant pointer. This is not the value of mptr, but we just call value of mptr, value of pointer. Colloquial terms in C++ community. Constant int ptr, and ptr is strictly speaking, technically speaking, or SSTS. Ptr is not a constant pointer, but when we say constant pointer, we usually mean a pointer declared with constant type pointer syntax. SSTS, the referenced operator, is not the value of ptr or the value of the pointer. It is the value of the object that the pointer is pointing to. But in C++ community, we commonly call it the value of the pointer. The Korean language is economic, scientific, and friendly to new technology and science. Pointer gap, just 4 syllables, correctly delivers the meaning of the value of the pointer. Pointer 참조값, just 6 syllables, correctly means the value of the object the pointer is pointing to. In this sense, Korean is science and technology friendly, which sadly is not with the English language. Sorry for my broken English. I have to fix this verb. I also have to fix this verb. The English is not my first language, and I have read a lot of English text, but I haven't spoke in English much. Please understand that when I talk and speak, teach C++ language through YouTube, I actually don't think much about my English grammar. I just speak as I think. I think more about the programming logic, not my English. My real writing skill is much better than my writing in these YouTube videos. Please subscribe to my YouTube channel. Thank you for watching.